So this is problem number 16. You're given two identical 12-volt batteries, each with the same internal resistance of 1.5 ohms, and you're told to find the voltage drop in this middle resistor shown here. So where I went wrong with this problem on the actual exam was a few nights before the exam, in the review session, we went over a similar problem that was very much the same as this one, except the terminals of this battery were flipped. So the current through this middle wire would have been canceled by the current from the other battery, and that would have been 0, so that's what I chose. But you have to pay attention in this problem because the currents will add up through this middle wire, so it's going to be non-zero. To get the correct answer, you could use the loop law and the junction rule. And these are two loops that I've drawn. You can choose either one because of the symmetry. And I've called the current through this wire I1 and the current through this middle wire I2. So using Kirchhoff's loop law, you get 12 volts minus 1.5 times I1, and then minus I2, because the resistor is just 1 ohm. That's equal to 0. And using the junction rule, you know that current through this wire plus the current through that wire must be equal to this current. And because of the symmetry, these two currents are the same, so 2I1 equals I2, and I1 equals 1/2 I2. If you plug that back into this top equation, you get this, and you solve that for I2, you get I2 equals 12 times 4/7, and that's 6.9 amps, roughly. So that's the current, but you need the voltage drop, and using V equals IR, where the resistance is just 1 ohm, you get 6.9 volts, which is C, the correct answer.